Welcome to Angles of Polygons. This is lesson 3.9, and our objective in this lesson is to develop an approach for finding the angle measurement sum for any polygon. So we're trying to find the sum and how we would find the sum of any of these polygons that I have listed here on this page. Now, one reminder is, hopefully you remember that every triangle always measures 180 degrees. And that does not matter if it's scalene, isosceles, or equilateral. All right, let's do a little review first with our multiplication and the steps to multiplication. Again, remember, IXL is a great site to practice many different skills on. Not just multiplication, but a lot of different things. So let's talk about the steps, though, that we can complete. So it says fill in the missing numbers. So if I do this, I do 6 times 1, and I would put 6. And if I did 1 times 8, I would put 8 there. Okay. And then on my 0, 2 times 6 is 12, carry my 1. 2 times 8 is 16, and 1 is 17. So there we did it. All right, so let's put in the missing ones here now, and all we need to do in this one is add. 8 plus 3 is 13, carry my 1. 8 plus 1 is 9. So 935 is what I get. Again, we need to finish our multiplying here. They did the first row for us. Now we're going to do the second row. So again, we have to put in our 0, our placeholder. I do 6 times 9, which is 54, and I carry my 5. And then I do 8 times 6, which is 48, plus my 5, which would be 53, and I carry my 5 over here. And let's see if I get the right answer. Looks like I did pretty good. So again, let's just do our adding on this one, and then we'll move on to angle measures. So 2 and 6. So there we go. All right, so let's move back to our angle measures, just a good review of multiplication. So moving on. It says, use a straight edge to draw a big triangle on a sheet of paper. Measure the angles and find the sum. Record the sum on a line plot. Now, first of all, the one thing I want you to know is that I do want you all to draw a triangle, whichever type of triangle you would like to draw. But I want you to think about measuring the sum of the angles. So we're going to analyze the data for the maximum, the minimum, range, median, and mode. Now, why are we going to do that? Interesting, right? So on the bottom of my sheet here, you see a line, a number line, and that's where we're going to record our data actually in class. But I want you to draw any type of a triangle you would like to, isosceles, scalene, equilateral, whatever you'd want, just using a straight edge, okay? And then bring it into class, and we're going to do some measuring, and we're going to talk about that. And where does your triangle fall on the line plot? Am I trying to trick you? I hope not. I hope you remember the rules with a triangle. So the sum of angles in a triangle. The sum of a triangle's angles will always be 180 degrees if measured correctly. What do you know about 180 degrees? What do we know about 180 degrees? What is 180 degrees? So again, we know what 180 degrees is, or at least I hope we remember what 180 degrees is. And if I am to draw a, oops, sorry, I'm trying to get this to work here. Draw a straight line, and it's not perfectly straight. But hopefully you all remember that a straight line is 180 degrees when we're talking about measuring. So let's keep going, because I want to show you what we're going to be working on in class. So it says, finding the sum of angles in polygons. The measure of the interior angles in a triangle is 180 degrees. The number of triangles with a polygon is 2 less than the number of sides of the polygons. Let's read that again. The number of triangles within a polygon is 2 less than the number of sides of the polygon. So let's take a look. So it says, if I look over here and it says my number of sides is 4, so then that means I have 2 less triangles, so that's 2. So I do my sum over here, and I do 2 times 180 equals 360. If I have 5 sides, again, 2 less would be 3. 3 times 180. 6 here would be 4. 2 less, 4 times 180. And if you're seeing the pattern, then I just keep kind of going. So as we're doing this, please write down the following ones. Let's do 7 times 5. So over here, we're going to write down 5 times 180. And let's go down and do these first. So let's do, so I have my blue, 13 and 2 less would be 11. And I hope you're with me here. 11. 26, so that'd be 24. Okay, and that's all I'm going to do with you. And I want you to finish doing 51, 63, and 85. And then I'd also like you to find out the total of each of the sums over here. So if you want to number your paper like 1, 2, maybe we could even do it like this. How about I put a 1 here? So 1, 2, 3, 4, 5, and so on. And then you can do, if you want to do your headings at the top, number of sides, number of triangles, and then the sum, that would be great too. So just make sure you figure out your angles or your totals for the sums. And all we're doing is multiplying again. Remember, 180 times 3, 180 times 4, 180 times 5. This one's 180 times 11 because we got bigger on the number of sides we had. So again, good practice with our multiplication and finding the sums of polygons. Okay, and at the bottom it says if n equals the number of sides in a polygon, blank equals the number of triangles within that polygon. And blank equals the sum of the angles in a polygon. Think about number 2. If you can figure it out, great, write down the answer to number 2. If you're struggling with number 2, don't worry about it. We're going to work on that one in class as well. Okay, moving on, let's try to finish up here with our lesson. Here is a review of expanded notation, and I wanted to go over this because, again, you're going to see this appear a lot in everyday math, and I thought this was just good practice for us. So, again, expanded notation. So if I did number 1 here, I'm going to do 6,000. Oops, got a little big there. 6,000 plus 400. Okay, plus 50 plus 6. All right, and then we have a decimal, which is just fine. So again, we do 60 plus 4. Oops, I'm back to black here. I switched colors. Plus 4 plus 0.5 plus 0.06. Okay, so there you go. Now, I'd like you to finish the last few on the page. Again, numbers 3 through number 7, okay? 3 through number 7. Now, number 3, again, expanded notation. Write a 4-digit numeral on number 5, and then you're going to write it in expanded notation. It says write the following expanded notation in standard form. Again, remember, standard form is your answer, okay? So standard form is what is the answer. In fact, standard form should look like number 1, 6,456, that's standard. Okay, the expanded is when we write it out. So good. And then we're going to build an 8-digit number, and it says you can use the clues and then write it in expanded notation. Okay, hopefully this is a good review for you. I'm going to check the problems in class so that we can take a score on all your problems because you've actually had to do quite a bit with this lesson. So let's do a little review of what you need to hand in. So when you're handing in, you're going to do numbers 3, number 4, number 5. So you're doing 3, 4, 5. You're going to do 5A and B. You're going to do number 6 and number 7A and B. So 3 through 7, just don't forget the A's and B's. All right, and on number 5, you're just finishing them up. I started them with you, so we're going to do number 1, and I numbered them for you, and you might want to put number of sides, make your little chart yourself. That way you have all the answers written down. Now, if you get number 2, that's great, and if you don't get number 2, don't worry about it. It's just good practice to see if you can figure out an algebraic expression without the numbers. Okay, so then again, hopefully you remembered that the sum of triangle angles will always measure 180. And what do we know about 180 degrees? And again, I hope you remember that 180 degrees is a straight line. Okay? And then moving on, we did a little bit of review here. You were just to draw a triangle. That's all I wanted you to do. Make sure your triangle isn't too teeny because we need them big enough because we're going to do an activity in class with your triangle. So we want to be able to cut it out. So maybe your triangle should go on its own sheet of paper. That might be a good idea. All right, and then we did a little review with multiplication, always a good review. And let's go back and see if we were able to get to our objective. And our angles of polygons, and we wanted to develop an approach for finding the angle measurement sum for any polygon. And I think we found a formula in which to do that. So again, lots to write down. Do your best. If you have questions, please remember you can always ask me, and have a great evening. Finish up your quiz as well.